and welcome to the students of 4th semester civil engineering students. Now, before entering into the subject, I will give a brief introduction to the subject. This hydraulic subject, the entire syllabus is divided into 3 parts: part A, part B and part C. Part A, it contains 3 chapters. First chapter is fundamentals of hydraulics, which carries 12 marks, and the second chapter total pressure and center of pressure, which carries 15 marks, and the third chapter flow of fluids. This chapter carries 20 marks. Part B, here 3 chapters. First chapter flow through orifices and mouthpieces, and the next chapter is flow over notches, and the 6th chapter is flow over weirs. And under part C, again 3 chapters: flow through channels, first chapter, which carries 20 marks, flow through pipes, which carries 15 marks, and pumps and turbines. So, this chapter carries 15 marks. So, here almost all the parts carries equal marks. In part A, 3 questions will be given, and you have to answer 2 questions. Similarly, in part B, 3 questions will be given, you have to answer 2 questions carrying 15 marks, and in part C also 3 questions will be given, and you have to answer 2 questions. So, total 30, 30 plus 30, so 90 marks. So, in section 1, 10 marks will be given, 5 marks for fill up the blanks and another 5 marks for short notes. Here this subject is somewhat typical. So, many students in 4th semester civil engineering students, they fail in this subject, because here the difficulty is many relations and many formulas are coming in the many chapters. So, the students, you should be well versed with the formulas. So, the system of units from one unit to the another unit, the substitution of units from one unit to the another unit. So, that should be correct, otherwise the problems will become wrong. So, the next point is the operation of calculator is very important. Many students they substitute the values to the formulas, but due to incorrect operation of the calculators, the answers will be wrong. So, these are all the difficulties the students are facing. Therefore, it is advisable to the students, they have to practice the calculators in homes. They have to work out the problems using calculators. Now, we shall enter into the first chapter, that is fundamentals of hydraulics. Here in this chapter, we are studying the fluids, classification of fluids and properties of fluids. Again, pressure and its measurements, definition of hydrostatic pressure, atmospheric pressure, gauge pressure, absolute pressure, vacuum pressure, intensity of pressure and pressure head, and finally, we are measuring the pressures by using manometers, that is differential manometer and simple manometer. Now, to start with the subject, that is fundamentals of hydraulics. So, now before entering into the subject, we should know the basics of the subjects. We should understand the definition of the fluid. Fluids in general includes liquids or gases. Fluid is a substance which flows from one point to the another point. Fluid always takes the shape of a container. Now, this is the definition of the fluid. Now, we shall move on to the next topic, branches of fluid mechanics. The fluid mechanics is that branch of science which deals with the behavior of fluids at rest as well as in motion. The study of fluids at rest is called fluid statics, and the study of fluids in motion is called fluid dynamics. The subject of hydraulics may be defined as that branch of engineering science which deals only with water. Here hydraulics means, hydra means water and lics means pipes. The flow of water through pipes is known as hydraulics. Next, the classification of fluids. Fluids are mainly classified into two types. So, first one is liquids and second one is gases. So, fluids in general we have understood that it is liquid or gas. Now, the definition of fluid is the fluids which cannot be compressible on the application of pressure and which occupies a definite shape of a container are known as liquids. Next, gases. The fluids which can be compressed or expanded are known as gases. The volume of a gas is subjected to changes on the application of pressure and temperature. So, here the gas can be compressed or expanded, that is on the application of pressure. The liquids may be classified into the following types. So, there are four different types of liquids. First one is ideal fluid, second one is real fluid, third one is Newtonian fluid and fourth one is non-Newtonian fluids. So, now let us understand what is ideal fluid. A fluid which incompressible and having no viscosity is known as an ideal fluid. Ideal fluid is only an imaginary fluid, therefore, no fluid is ideal in nature. Second one is real fluids. A fluid which possesses viscosity is known as a real fluid. In actual practice, all existing fluids are real fluids. Next, number 3, Newtonian fluids. A real fluid in which the shear stress is proportional to the rate of shear strain is known as a Newtonian fluid and it obeys Newton's laws of motion. Non-Newtonian fluids. A real fluid in which the shear stress is not proportional to the rate of shear strain is known as a non-Newtonian fluid and it obeys Newton's and it does not obeys Newton's laws of viscosity. Next, we shall move on to the next fluids and their properties. So, these properties of fluids, they are very important. In the next coming chapters, so we should understand the definitions of these properties of fluids. So, in your examination also you will get the questions on these fluid properties. So, here following are the properties of fluid. First one is density or mass density, and second property is specific weight, third property is specific gravity, next one is surface tension, next capillarity and viscosity. Now, we shall understand the definitions of these properties one by one. Density or mass density, this is also known as mass density. So, in your examination you will get this definition for 2 marks: density, specific weight, specific gravity, viscosity, compressibility, etc., etc. For all these properties they carry 2 marks. Now, density or mass density, the definition of density is: density of a fluid is defined as the ratio of mass of fluid to its volume. Thus, the mass per unit volume of a fluid is called density. Mathematically, it is represented by a symbol rho, and it is given by mass of the fluid whole over volume of the fluid. It is expressed as kg per meter cube. The value of density of water is 1 gram per centimeter cube or 1000 kg per meter cube, and this is also equal to 1 ton per meter cube. Though we are following SI units, the density, the unit of density is 1 gram per centimeter cube or 1000 kg per meter cube. Next, specific weight. The specific weight of a fluid may be defined as weight per unit volume, and it is denoted by small w, and mathematically it is given by W is equal to weight over volume. The specific weight of water is taken as 9.81 kN per meter cube. So, this is meter cube. Now, the definition of specific weight is very important. Once again, the specific weight of a fluid Now, the another important property, that is specific gravity. Specific gravity of a liquid may be defined as the ratio of its specific weight to that of a standard substance at a standard temperature. For liquids, pure water is taken as standard substance. Now, mathematically this can be written as specific gravity is equal to specific weight of a liquid whole over specific weight of pure water. Always the specific gravity of pure water is taken as 1. The next property of the liquid is surface tension. Now, look into the sketch. So, here we are observing two sketches. We can understand the concept of surface tension by referring to the two sketches. Surface tension means the surface tension is its property which enables it to resist tensile stresses. It is due to the cohesion between the molecules at the surface of a liquid. The effect of surface tension of a liquid may be easily seen in the case of smaller diameter tube open to the atmosphere. When a glass tube of smaller diameter is dipped in water, the water rises up as shown in the figure with a upward concave surface. So, this is as shown in the figure. So, upward concave surface, but when the same tube is dipped in mercury, the mercury depresses down. So, this is also shown in figure and with an upward concave surface, that is as shown in the figure. Next property, compressibility of liquids. The compressibility of a liquid may be defined as its volume goes on changing on the application of pressure. On the other hand, an incompressible fluid is one whose volume does not change on the application of pressure. All gases are considered as compressible fluids. Liquids possess very small compressibility, but for all practical purposes this can be neglected. Therefore, all liquids are considered as incompressible liquids. Next property is capillarity of water. Now, look at the sketch, the effect of capillarity. When a tube of smaller diameter it is dipped in water, the water rises up in the tube with an upward concave surface. The rise of the liquid surface is known as capillary rise, but when the same tube is dipped in mercury, the mercury molecules depresses down in the tube with an upward concave surface, convex surface. The fall of liquid surface is known as capillary depression. It is always expressed in terms of millimeters or centimeters of liquid. Its value depends upon the specific weight of the liquid, diameter of the tube and surface tension of the liquid. Now, the last property is viscosity. We see that the flow of thin liquids such as alcohol or water is much easier than thick liquids such as syrup or heavy oil. Therefore, each liquid possesses some property which controls its rate of flow. This property is termed as viscosity. Now, after understanding the different properties of liquids, so we shall work out some simple problems on this chapter. So, here before starting of the problems, so we should know the specific mass of the liquid. The specific mass of the liquid is given by weight over acceleration due to gravity. Now, we shall work out the problem. First problem, in an experiment the weight of 2.5 meter cube of a certain liquid was found to be 18.75 kilonewtons. Find the specific weight of the liquid. Also find its density. So, here writing the given data is very important. So, now here it is given volume is equal to 2.5 meter cube and weight is equal to 18.75 kN. So, we have to write the units in the same units in the same system of units. Solution. So, we know that the specific weight of the liquid, it is given by W is equal to weight over volume. So, this is equal to 18.75, that is weight divided by 2.5 meter cube volume, and we will get 7.5 kilonewton per meter cube. So, next problem is, we have to find out the density of the liquid. Mass of the liquid is equal to weight over acceleration due to gravity, that is 18.75 divided by 9.81. So, this gives 1.91 ton per meter cube, and finally, density of the liquid is equal to mass over volume. So, substitute the values 1.91 over 2.5. So, you will get 0.764 ton per meter cube. So, which is also equal to 764 kg per meter cube. Next problem, find the specific gravity of an oil whose specific weight is 7.85 kN per meter cube. So, here specific weight of oil is given and we have to determine the specific gravity. We know that the specific gravity of oil is equal to specific weight of oil over specific weight of pure water. Now, substitute the values. Specific weight of oil is 7.85 and specific weight of pure water. So, this is taken as 9.81. So, this gives you 0.8. No units for specific gravity. And next, third problem. A vessel of 4 meter cube of volume contains an oil which weighs 30.2 kN. Determine the specific gravity of oil. So, here the given data is volume is equal to 4 meter cube and weight is equal to 30.2 kN. We know that the specific weight of oil, that is equal to W, and which is given by weight over volume, and substitute the values. Weight is equal to 30.2 and volume is equal to 4. So, you will get 7.55 kN per meter cube, and finally, the specific gravity of oil is equal to specific weight of the liquid whole over specific weight of pure water. Now, substitute the values. Specific weight of the liquid is equal to 7.55 and specific weight of pure water is 9.81. So, which is equal to 0.77. This is the answer. Next, last problem. Calculate the specific weight, specific mass and specific gravity of a liquid having a volume of 4 cubic meters and weighing 29.43 kilonewton. So, this problem appeared in November 2011 carrying 6 marks. So, here the given data is volume is equal to 4 meter cube and weight is equal to 29.43 kN. Next, solution. We know that the specific weight is equal to W, and which is given by weight over volume, and that is equal to, so substitute the values, 29.43 it is given, and volume 4 meter cube. So, you will get 7.357 kN per meter cube. So, next, specific mass. We know specific mass is equal to weight over acceleration due to gravity. Substitute the values, weight is equal to 29.43 and acceleration due to gravity is 9.81, which gives you 3 ton per meter cube. And finally, specific gravity is equal to specific weight of the liquid over specific weight of pure water. Now, this is equal to, specific weight of the liquid is 7.357 over specific weight of pure water is 9.81, which gives you 0.749. So, next, these are the problems. Now, you can take down the problems 5 and 6 and you can work out in your homes. Now, the problem of number 5 is, what is the specific weight of the liquid whose specific weight is 7 point, this is specific gravity. What is the specific gravity of the liquid whose specific weight is 7.36 kilonewton per meter cube. So, next problem is, a certain liquid occupying volume of 1.6 meter cube weighs 12.8 kilonewton. What is the specific weight of the liquid? You work out these problems in your homes. Now, in this class we have understood what is a fluid. Now, fluids in general we have understood. So, it includes liquids or gases, and fluid is a substance, it flows from one point to the another point and it occupies the shape of the container, that we have understood. And next we have understood the branches of fluid mechanics. Now, fluid mechanics is that branch of engineering science which deals with the behavior of fluids as well as in motion. The study of fluids at rest is known as fluid statics, and the study of fluids in motion is called fluid dynamics. So, finally, the subject of hydraulics may be defined as the branch of engineering science which deals only with the behavior of water. So, these definitions we have understood, and classification of fluids, two types of fluids, liquids and gases we have understood. Liquid means the fluids which cannot be compressed on the application of pressure and which occupies a definite shape of a container are known as liquids, and gases we understood the fluids cannot be the fluids which can be compressed or expanded on the application of pressure and temperature. The liquids may be classified into the different types, that is, first one ideal fluid, real fluid, Newtonian fluid and non-Newtonian fluid. Ideal fluid means the fluids which are incompressible and having no viscosity and is known as a ideal fluid. So, these fluids are imaginary fluids, and therefore, no fluid is ideal in nature. Real fluids means they possess viscosity and in actual practice all the existing fluids are real fluids. Newtonian fluids means, so the ratio of shear stress to the shear strain is proportional and is known as a Newtonian fluid, and it obeys the Newton's laws of viscosity. So, non-Newtonian fluids means So, the shear stress is not proportional to the rate of shear strain, and it does not obeys Newton's laws of viscosity. And we have also understood the different properties, that is density, specific weight, specific gravity, surface tension, compressibility, capillarity and viscosity. Now, the density, it is defined as the mass per unit volume of a fluid, and it is expressed in kg per meter cube. Specific weight, the specific weight of a fluid may be defined as the weight per unit volume, and it is denoted by small w, where small w, that is the specific weight of water, is given by 9.81 meter cube per 9.81 kN per meter cube. So, specific gravity, so it is nothing but, it may be defined as the ratio of its specific weight to that of a standard substance at a standard temperature. So, for all liquids, pure water is taken as a standard substance, and the specific gravity of pure water is taken as 1. And also we have understood what is surface tension. The surface tension is its property which enables it to resist tensile stresses, and this is due to the cohesion between the molecules at the surface of a liquid. And this can be understood by dipping a smaller diameter tube in a water. So, when the water rises up in the glass tube, forming a concave surface, and in and the same smaller diameter tube, when it is dipped in mercury, the mercury depresses down. So, all these things happens due to surface tension. And compressibility. So, compressibility means the another property, compressibility. The compressibility of a fluid may be defined as its volume goes on changing on the application of pressure, but whereas an incompressible fluid is one whose volume does not changes on the application of pressure. And we also understood all gases are considered as compressible fluids, and liquids possesses very small compressibility, but for all practical purposes this can be neglected. Therefore, all liquids are considered as incompressible liquids. So, another property we have understood, that is the capillarity. So, this is also when a tube of smaller diameter is dipped in water, the water rises up in the tube with an upward concave surface. The rise of liquid surface is known as capillary rise, but when the same tube is dipped in mercury, the mercury molecules depresses down. So, this is known as the capillary depression, and it is always expressed in mm or cm. Its value depends upon the specific weight of the liquid, diameter of the tube and surface tension. And finally, the viscosity. So, the viscosity of water, the viscosity of liquids such as alcohol, water is much easier than liquids such as syrup or heavy oil. Therefore, each liquid possesses some property which controls its rate of flow. This property is termed as viscosity, and we have worked out some simple problems on this, and you work out the problems 5 and 6, and we shall continue the next portion in the next class. Okay, thank you.